Morning, students. So, in our last class, we studied about the basics required for understanding the working of a transformer and its relevant equations, the equations that are coming in material science, such equations, then the right-hand curl rule, and Faraday's law of electromagnetic induction, what it is, then Lenz's law. So, all these things were covered in the last chapter, last class, and today we will be looking at the working principle of a transformer and like more adding more things to our last class. So we know that transformer is a static machine and it has two main parts. It has a core. This is the core. This is the core and this is the winding. Okay, and the main function of a transformer is to be it will be stepping up or stepping down of the AC voltage, and it also has efficiency as high as 99%. Then in the last class I told you about some other advantages, like which are they, like it isolates the DC while it permits only the AC, and it is used for impedance matching so that we get the maximum power transfer from source to load. So advantages are like it is stepping, the main basic advantage is stepping up and stepping down of AC voltage. Then it permits only the AC voltage and there is no transfer of DC through a transformer. We use some other devices for stepping up and stepping down of the DC voltage. And then it is also used for impedance matching. Then another factor which I told in doing for the use of transmission is during use of transformer is during transmission of power. Like if the voltage is stepped up, means correspondingly the current will be becoming less, because for a transformer is actually a constant power devices. So primary and secondary side, the kVA value will be same. So proportionally, if voltage increases, the current will be decreasing. Okay. So the two main parts are core and winding. Then we have the primary side and we have the secondary side. And this we call the primary coil, which is having N1 number of turns, and the secondary coil is having N2 number of turns. And you know, to determine the direction of the current, here we use the right hand curl rule or Maxwell corkscrew rule. We call it all these different names. So that rule also I have already explained to you. That means if the thumb shows current, then the magnetic field will be shown by the curl of right hand curl. And similarly, if the right hand curl shows the current, then the magnetic field will show, the direction of the thumb will show the direction of the magnetic field. This is all from the last class. So now we can say that the working principle of a transformer is based on mutual induction between the primary and the secondary circuits linked together by a common magnetic circuit. Sorry, this is transformer, not transformed. So the working principle of transformer is based on mutual induction between the primary and the secondary circuit. So this is the primary, and this is the secondary, and they have a common magnetic circuit in between. I already explained that in the last class. Okay, and so mutual induction is happening here. So this is based on Faraday's law of electromagnetic induction. So what does Faraday's law states? It states that an EMF is induced across the coil if magnetic flux linking a coil changes. So an EMF. So which are the coils here? We have N1 here in the primary and N2 here in the secondary. So an EMF, and there is a flux phi present in the magnetic core. So an EMF will be induced both in the primary as well as secondary. Here it will be E1 and here it will be E2. And what's the property of that induced EMF? It is like what is the property? It will be proportional to the rate of change of flux with respect to time. That is, E1 is proportional to d phi by dt, because flux is common. The flux involved in the primary as well as the secondary is common. So E is proportional to d phi by dt as well as E1 is proportional to d5 by dt as well as E2 is also proportional to d5 by dt. Only the proportionality constant will be different. The proportionality constant, that is, in case of primary, it is E is equal to N1 into d5 by dt, and in case of secondary, E will be equal to N2 into d5 by dt. So, in the last class, we also saw that there is a negative sign coming in when we write Faraday's law of electromagnetism. We normally write E is equal to minus N into d phi by dt. This minus sign indicate the property of Lenz's law. What does Lenz's law state? Lenz's law state that the polarity of the induced EMF should be such that if it allows to cause a current, then the current so produced must oppose the cause. So what is the cause here? Here the cause is change in flux d phi by dt. So the current so produced must oppose the cause of the current. Okay. So this my negative sign does not have anything to do with the magnitude. It just shows that it opposes. Okay. Okay. So the primary and the secondary windings, they are electrically separated. You see, it also, we can say another application of transformer, we can say that it provides an electrical isolation. So the primary and secondary windings are electrically separated but magnetically linked through a path of low reluctance provided by iron core. Okay, the core is made up of iron. When primary winding is energized by AC source, an alternating flux is set up in the core. Okay, that is, alternating flux will be set up in the primary core. So this and rate of change of that flux will produce E1 is equal to N1 into d phi 1 by dt. An alternative flux is linked up with the secondary winding in which it produces mutually induced EMF. So in the primary winding, it will be self-induced EMF, and because we are giving the supply, we are giving the supply to the primary winding, and one EMF is that it will be self-induced EMF, and the EMF produced in the secondary winding will be mutually induced EMF according to Faraday's law of electromagnetic induction. Okay. Now we can see that some key points we can take out from our discussion up to this. There is no electrical connection between primary and secondary winding. So I have already explained. It transfers electrical power from one winding to another. Okay. Electrical power is transferred by induction. So in primary winding, it is self-induction, and in the secondary winding, it is mutual induction. So normally, if a question comes, what happening means, you should write mutual induction, because the output that we get in the secondary is what we is important for us, because then that is where this transformer function happens. So mutual induction. So, and the frequency remains same at both the primary and the secondary side. The frequency will be 50 hertz on the primary as well as the secondary side, and it is also a constant flux device. You see here we saw that the flux linked to this phi everywhere, so it's a constant flux device. Okay. Now let's see some other facts. So when V1 is applied to the primary, an alternating flux phi is set up in the core. I already explained. V1 is applied to the primary, and an alternating flux phi 1 is set up in the core, iron core. So the alternating flux is links of both the windings, that is both primary and secondary windings. That's why we say that transformer is a constant flux device, and induced EMF E1 and E2 according to Faraday's law of electromagnetic induction. Already the same only. Just to make it more clear, and for in an examination point of view, I am explaining. You should write all these things you should write in your university exam. So E1 is the primary EMF and E2 is the secondary EMF. So I already told E is proportional to d phi by dt. That is rate of change of flux with respect to time. And E is equal to minus n d phi by dt, and it will be n1, and or else it will be n2, and minus sign denotes that according to Lenz's law, it opposes the rate of change of flux. That is, opposes the cause. So by Faraday's law, E1 is equal to minus N1 into d phi by dt and E2 is equal to minus N2 into d phi dt. And this equation is very important. So taking the ratio, we get E1 by E2 is equal to N1 by A2. So because rate of change of flux is common, because it is a common flux only. So at a particular instant, that is at a particular instant of time, that is t is equal to 2 seconds or t is equal to like half a cycle or whichever we are taking, we can say that E1 by E2 is equal to N1 by N2. So to summarize, we have step up transformer is N2 is greater than N1. That is the number of turns in the secondary is more compared to the number of turns in the primary. Therefore, we will get E2 is greater than E1 or V2 is greater than 1, and similarly I1 is less than I2. Then step down transformer is N2 means that is secondary winding will be less. So similarly, the EMF induced will be less and the EMF in the load will also be less. But in that case, the current will be more. We saw that in the first session. What is happening in the primary and secondary, and this is during transmission, we use this. Transmission of electric power, we use this. So before moving to the EMF equation, we can conclude that for an ideal transformer, so ideal transformer will be covered in the next session, but still an ideal transformer is a transformer which has no losses, no leakage current, nothing. It is a perfect one. So whatever we give in the primary, we get exactly in the secondary, 100%. But such a transformer is not possible. It is not available. It's an ideal condition that we take. In that case, we can write like V1 by V2, I have not mentioned here, V1 by V2 is equal to E1 by E2 is equal to N1 by N2 is equal to I2 by I1. Okay, I'll repeat once again. The reason why I mentioned it is deliberate only. I want you people to think how it came. V1 by V2 is equal to E1 by E2 is equal to N1 by N2 is equal to I2 by I1. Now we will move on to the EMF equation of a transformer. So we have a transformer here. N1 is an N1 number of turns in the primary, N2 number of turns in the secondary. The voltage V1 is provided, and E1 and E2 are the induced EMF. And we have we have the flux phi linking the iron core. Okay, so this is in maximum value 5M and 5M, and this is the total time period T, and half a cycle is T by 2, and half of that is 45 degrees T by 4. So we have phi is equal to 5M sine omega T. So this sine wave, it is sine wave, so it is 5M sine omega T. So according to Faraday's law of electromagnetic induction and Lenz's law, we can write in the primary side E1 is equal to N1 into d phi by dt, because we are not considering the negative sign, because it just shows that it is it acts opposite to it, it is just showing Lenz's law, nothing to do with the magnitude. So we are not taking minus sign, we'll just go with the magnitude only. So primary side E1 is equal to N1 into d phi by dt. So here we can say d phi will be change in flux. So initially we'll go for T by 4. We'll go for 45 degree. So d phi is equal to change in flux will be phi 2 minus phi 1. That's 5m minus 0, that is will be 5m. And change in flux dt will be, that is change in time will be t by 4. So dt will be t by 4, which is equal to 1 by 4f. Okay. How it become 1 by 4f? Because time period is equal to 1 by frequency. Okay. Now we have, according to Lenz's law, E1 is equal to N1 into d by dt of 5m sine omega t. So 5 is substitute as 5m sine omega t. So N1 into 5m into d by dt of sine omega t. So N1 into 5m into cos omega t. Then cos omega t we can write as N1 into 5m into omega. So d by dt of sine omega t will be N1 into 5m into omega into cos omega t. There is one omega coming here. Please note that there is one omega here. Okay, this one omega also will come here. sorry, I forgot to mention that omega here. Then n1 into omega in phi m into omega into sine of omega t plus 90. You know that cos is a trigonometric aspect. It will be okay, and then we'll go like we also have omega is equal to 2 pi f. Okay, so so omega is equal to 2 pi f also. Then E RMS is n1 into phi m into omega by root 2. Okay, because the maximum value E RMS is em by root 2. So here the maximum value will be n1 into phi m into omega by root 2. So we substitute and we get it as E RMS is equal to root 2 into pi into phi into omega phi m into n1. Okay. So ERMS will be root 2 into pi into f into phi m into n1. And similarly, we will go out for E2RMS. So E2RMS will be n2 into d phi by dt. So all this process similarly we will do, and we will get as root 2 into pi into f into phi m into n2, because omega we will substitute as 2 pi f. Where the omega came from, because d by dt of sine omega t is cos omega t into omega. Okay. So when we bring n1 to the left hand side, we can see that this expression for EMS, E1 RMS and E2 RMS is same. So E1 RMS by N1 is equal to E2 RMS by N2. So EMF per turn on the primary side of the transformer is equal to EMF per turn on the secondary side. So A is proportional to d phi by dt and E is equal to N into d phi by dt. So N into phi m minus 0 by 1 by 4f. Right? 5 we have phi m minus 0, so 1 by 4 of. So we got E is equal to n into phi m minus 0 by 1 by 4 of, which will be 4 into f into phi m into n, and this is the average value. We have another relation. What do you mean by form factor? Form factor is RMS value by average value. So for a sine wave, form factor is 1.11. It actually has another derivation, but you need not go for it. We need to consider the frequency and all, and we'll get one expression. So you need not go for it. Just understand that for a sine wave, form factor is equal to 1.11. So RMS value by average. So RMS value is equal to 1.11 into average value. So we go for RMS value of the primary side is 1.11 into average value. That is 1.11 into 4 into f into phi m, which is equal to 4.44 into f into phi m into n1. This is the RMS value of the induced EMF in the primary. So similarly, we will get E2 is also 4.44 into f into phi m into n2. So this is the EMF equation of a transformer in the primary as well as secondary, and we can here also we can see that if we bring n1 or n2 the left hand side, the EMF per turn of the transformer on both the side of the primary and secondary is same. You should not say that EMF is same. EMF per turn is same on the primary as well as the secondary. So far in this class, we understood what is the principle of operation of the transformer. Then what is Faraday's law, Lenz's law, all covered in the last class as well as this class also I have explained. Then constant flux device, constant power device, and all these features, and EMF per turn is same. EMF equation of the transformer, very important in terms of university examination point of view. Okay, thank you.